This is Precalculus Section 1.3 Day 1 Notes. Today we are going to be talking about combining algebraic expressions, and everything from this section today is going to be review. So we're just going to dive right into our examples here. In example number 1, we've got a polynomial and we are asked to combine like terms. So our first step here is going to be to distribute the negative sign in front of the parentheses. So this negative sign is now going to belong to all terms after it. So we have 12x cubed minus 5x plus 8 minus 3x. Now minus negative 6x cubed becomes a positive 6x cubed, and minus positive 7x becomes a negative 7x. Now I like to do what I call in Algebra 1 the box, circle, underline method for like terms. So I'm going to start with, because we want our terms to be in descending order, I'm going to start with the highest exponent that I have, which is cubed terms. So I'm going to combine my 12x cubed with my positive 6x cubed. That is going to give me 18x cubed. Next I would do x squareds, but I don't have any x squareds. So then I'll go to my x terms. I have a negative 5x and a negative 7x, which gives me a negative 12x. Whoops, and I forgot my negative 3x. Whoops. Backtrack there a second. Oops. I have negative 5x, negative 7x, and negative 3x, which gives me a total of negative 15x. And then all I have left here is my constant term, which is a positive 8. So there's my final answer. In number 2, I have distributive property twice. So I have to distribute the 4, and be careful here, I have to distribute the negative 5. So 4 times 2x gives me 8x. 4 times negative 5 is negative 20. Negative 5 times 11 is negative 55, and negative 5 times positive 3x is negative 15x. Now combining like terms, again, start with your highest exponent, which in this case is just x to the first power. So I'm going to combine my 8x with my negative 15x. That's going to give me negative 7x. And then my constant terms here, negative 20 plus negative 55 is going to give me a constant term of negative 75. And there's my final answer. In the next expression, I am multiplying two binomials together. So this process is where we need to FOIL, okay? Now FOIL is an acronym for those of you that are a little rusty. It stands for first, outer, inner, last. So when I multiply my first term times my first term, 2x times 4x, I get 8x squared. O stands for outers. So I'm going to multiply my 2x times my negative 1. That's going to give me negative 2x. My inners means the 7 times the 4x. That's going to give me positive 28x. And then my lasts is the 7 times the negative 1. That gives me negative 7. And then the last step here is the O and the I terms here are like terms, so I need to combine those. So my final answer is going to be 8x squared plus 26x minus 7. In number 4, I have a binomial squared, okay? So my first step here is going to be to write two of them. This squared right here really means that I have 5y plus 7m times another 5y plus 7m. And when I FOIL this out, I'm going to end up with 4 terms. 5y times 5y is going to give me 25y squared. 5y times 7m is going to give me positive 35. And you could either write my or ym. It doesn't matter. I'm going to write my just because that would be alphabetical. My inners, it's going to be 7m times 5y again. So that's going to be another 35my. And then finally my last, 7m times 7m, is going to give me 49m squared. Now, combine like terms. We have 25y squared plus 70 my plus 49m squared. And there's our final answer. In number 5, okay, we're going to be foiling again. We're multiplying a binomial times a binomial, but notice we've got some rational exponents here. So we want to remember that when we're multiplying powers with the same base, which we're going to be multiplying an x times an x, that we add our exponents when we multiply according to our exponents rules, okay? So once again, I am going to FOIL, first times first. X to the 2/3 times x to the 1/2. I'm going to have to add 2/3 plus 1/2. I'll get to that in a minute. Then my outers, it's going to be x to the 2/3 times -7. So that's just going to be -7x to the 2/3. My inners, that's going to be positive 5x to the 1/2. And then my last 5 times -7 is going to be -35. Okay, so now I have to add 2/3 plus 1/2. A good common denominator for 2 and 3 would be 6, right? So then this is going to be x to the, 4/6 plus 3/6 minus, let's see here, I can combine these together. Oh no, actually I lied. I can't combine those together. They're not like terms, right? They don't have the same root. So I've got -7x to the 2/3 plus 5x to the 1/2 minus 35. So then 4/6 plus 3/6 would give me 7/6. So final answer here is going to be x to the 7/6 power minus 7x to the 2/3 power plus 5x to the 1/2 power minus 35. And that's how I'm going to leave my answer. Now, I do want to stop for a second because I'm sure some of you are thinking, well, should we have those as exponents, or since they're rational exponents, should we write those as radicals? And that's a great thing to think about. But a little note here that we might want to add is just that if the question or if the problem is in exponent form, leave answer in exponent form. If the problem's given in radical form, then give your answer in radical form. Okay, good rule of thumb. All right, number 6, looks like we're multiplying a binomial times a trinomial. So this is basically just distributive property 2 times. We have to take the x squared and multiply it times all 3 terms. And then after that, we have to take the 3 and multiply it times all 3 terms. X squared times 3x squared is going to be 3x to the 4th. X squared times -5x is going to be -5x cubed. And x squared times -7 is going to be -7x squared. Now I'm going to multiply the 3 times everything. 3 times 3x squared is going to be 9x squared. I'm going to go ahead and I'm going to write that under the -7x squared because they're like terms. 3 times -5x is -15x, and 3 times -7 is -21. So now I'm going to combine my like terms, but really the only 2 like terms that I have are those x squared terms. So I'm just going to have a lot of terms in my answer. 3x to the 4th minus 5x cubed plus 2x squared minus 15x minus 21. And again, I can't combine this or simplify this any further because these are all different terms. They all have different exponents. Finally, number 7, okay? So I've got a monomial times a trinomial. My job here is going to be to distribute the monomial first, okay? Then after that, I'll take a look and see what I have. When I distribute my monomial, x cubed y squared times x squared, again, I'm multiplying an x times an x, so I'm going to add those exponents, so that's going to be x to the 5th y squared. And then x cubed y squared times -3x, that's going to be -3. The x cubed times the x is going to make x to the 4th y squared. And then plus 2 x cubed y squared. And guess what? That's it. Because all 3 of those terms are different, they cannot be combined.